In this video, we're going to look at sum and difference identities for trig functions. And if we think about it, there's one reason that we use them. Sum and difference identities are used to convert angles that we aren't familiar with to ones that we are familiar with. And I wouldn't really say convert, but if we wanted to find, for example, the sine of 75 degrees, well, we don't know that from our unit circle from the right triangles that we know, the 30, 60, 90, and the 45, 45, 90. But we do know that sine of 75 could also be written as 45 plus 30. Now that's inside of these parentheses, right? But that's not the same as doing sine 45 plus sine of 30. Okay, so if we look at it, if we said sine of 75 degrees, that's not going to be the same as, so let's say it is the same as sine of, and then in the parentheses, 30 degrees plus 45 degrees, because I can work within the parentheses, but that's not going to be the same as sine of 30 degrees, and then plus, this is outside of the parentheses of that trig function. It's not the same as that. And we can prove that pretty quickly. Let's go back up to the first page here and say, let's think about sine of 90 degrees. We know sine of 90 is 1. Okay, now let's think about what is sine of 60 degrees plus the sine of 30 degrees. Well, the sine of 60 is root 3 over 2, and the sine of 30 is 1 over 2. And when I add those, I get root 3 plus 1 over 2. And this is not the same as the number 1. That's a different number than 1. If we plug that into our calculator, we get square root of 3 plus 1 divided by 2. We get 1.37. That's not the same. Okay, so the sine of 90 degrees can't be broken up into two separate sine functions. So we have some identities that we're going to use throughout this unit. And I have a link. You don't need to use this link here. I have a link to watch. If you would like to see the proof for these identities, you're welcome to watch that. But these are the 6 identities. You need to know these. I want you to pause and write these in your notes, but also know that these are on the reference sheet. Okay, so the reference sheet that we handed out has these. So if we wanted to look at cosine of a plus b, so for example, cosine of 75 degrees, what we're going to do is we're going to split that 75 into 2 that we know. And so we could say that's the cosine of 30 degrees plus 45 degrees. And now what happens is this is the A value and this is the B value in our formula. And so to find the cosine of 75 degrees, it would be the cosine of 30 degrees times the cosine of 45 minus the sine of 30 degrees times the sine of 45. So we would plug those A and B values in. And you can see for cosine, it's cosine, cosine, and then the sign that's inside the formula changes. So if it's a plus A plus B, then it's minus sine A sine B. And cosine A minus B is cosine, cosine. And then since it's a minus, we have a plus over here. And again, I can give you links to all of these proofs if you would like to see how they were derived. And then for sine A plus B, you have sine of A times the cosine of B plus sine of B times the cosine of A. And sine of A minus B is sine of A cosine of B minus sine of B cosine of A. So I always point out when I'm teaching this that on the cosines, the sign inside changes in the formula. And on sines, the sign inside stays in the formula. But again, you don't have to memorize these formulas. They're on your reference sheet. And then you want to probably write down the tan formula, that tan of A plus B is tan of A plus tan of B divided by 1 minus tan A times tan B, and likewise your tan A minus B. Okay, so how do we use these? We're going to walk through a couple of problems, and then you have some for homework. So let's try this one together. So we will be looking for cosine of 75 degrees. And so we're going to break this up into cosine of 2 that we know. So we're always looking for 2 that we know. Okay, sometimes there's more than one option for the 2 that you know. Like 90 could be 30 plus 60 or 45 plus 45. Okay, so now we know that the formula for cosine A plus B is cosine of A cosine of B minus sine of A sine of B. And so in this formula, we're going to have A is 30 and B is 45. So I'll rewrite that as cosine of 30 degrees cosine of 45 degrees minus sine of 30 degrees sine of 45 degrees. And now we plug in. We plug in what we know. So the cosine of 30 is root 3 over 2. The cosine of 45 is root 2 over 2. And that's multiplied. Minus the sine of 30 is 1/2. The sine of 45 is root 2 over 2. And then we're going to use our arithmetic skills. So root 3 times root 2 is root 6. 2 times 2 on the denominator is 4. Minus 1 times root 2 is root 2. On the denominator is 4. And so this is root 6 minus root 2 all over 4. Okay, and sometimes, and I don't have a preference here, but sometimes you see how there's you can factor this. It could be root 6 times we could put this onto our denominator. We could have taken this and without simplifying the front one, we could have said root 3 times root 2 minus 1 times root 2 over 4. And so sometimes you'll see this one written with the root 2 factored out. I think that this is the better way to write it, okay? So now let's go down and see. I think this one does it out for you. So root 6 minus root 2 over 4. Okay, another example, one with radians. Find the exact value of sine of pi over 12. So now when we're in radians, the 12th of radians, those are 15-degree increments, okay? But what you really want to think about is this. Pi over 6 is the same as 2 pi over 12. Pi over 4 is the same as 3 pi over 12. Pi over 3 is the same as 4 pi over 12. Okay, so when you have over 12s, you can use those combinations, and you could keep going. Pi over 2 is 6 pi over 12. We could keep going in the 12s. So we want sine of pi over 12. So sine of pi over 12, well, I'm going to use 4 and 3. You could have used 3 and 2. Okay, so I guess maybe I'll use 3 and 2 instead, but you can use any combination that works. So I'm going to say that this is the same as 3 pi over 12 minus 2 pi over 12. And that's the same as sine of pi over 4 minus pi over 6. Okay, so here's our formula. Sine of A minus B is going to be sine of A. And so I'm just going to put my little A and B's over these and plug it in right away. So here's A and here's B, right? So sine of A is sine of pi over 4. Cosine of B, cosine of pi over 6. And then we have minus sine of B, sine of pi over 6. Cosine of A, cosine of pi over 4. And now we can plug in the values we know. So sine of pi over 4 is root 2 over 2. Cosine of pi over 6, root 3 over 2. Sine of pi over 6, 1/2. Cosine of pi over 4, root 2 over 2. And so we're going to get that the sine of pi over 12 is equal to root 6 over 4 minus root 2 over 4. And so the sine of pi over 12 is equal to root 6 minus root 2 over 4, which, by the way, is the same value as what we got for the cosine. So remember, right? So let's go back up here, right? Root 6 minus root 2 over 4 was the cosine of 75. And so if we think about it, sine of 15 degrees, you're over here. So you're looking at the y value there for 15 degrees, pi over 12. 75 degrees is up here, and that's what we did on the first example. And the cosine is the x value. And so those two numbers end up being the same value, just the two examples that we had first are the same. Okay, so here's the work done out again, but I did that on the previous slide. Okay, so here's one for you to try. Which is the exact value of this expression? So 7 pi over 12. So I'm thinking, okay, I need to know 7 pi over 12 could be 3 pi over 12, which is pi over 3, plus 4 pi over 12, which is, so the first one's pi over 4, and the second one is pi over 3. And so I could rewrite this as sine of pi over 4 plus pi over 3, because that would be 3 pi over 12 plus 4 pi over 12, which would be 7 pi over 12. Okay, so go ahead and plug that into the formula. Sine of A, cosine of B, plus cosine of A, sine of B. Okay, and the formula that I had given you earlier was, I wrote it in sine of pi over 4, cosine, so sine of A, cosine of B, plus sine of B, cosine of A. Your book gives it to you this way, the textbook. These are the exact same expression. I just reversed which one came first in the second term. Okay, see what you get and click in your answer. Great, and now when we finish it, we're going to say root 2 over 2, sine of pi over 4, cosine of pi over 3 is 1/2, plus sine of pi over 3, root 3 over 2, cosine of pi over 4, root 2 over 2. And so we get root 2 over 4 plus root 6 over 4, which is equal to root 2 plus root 6 over 4. So that's the exact number. Now you could type that into your calculator and get an approximation. And so the correct answer here is A. Okay, try this next one. Tan of 15 degrees. So we need two expressions that we know. So we could either do 60 minus 45, that's 15 degrees, or we could do 45 minus 30, that's also 15 degrees. So I'm going to use 45 minus 30. So I'm going to say tan of 45 degrees minus 30 degrees. And since this is an A minus B, we're going to say that this is tan of A, tan of 45 degrees, minus tan of 30 degrees, divided by 1 plus tan of 45, tan of 30. And I always find it useful to just, for the tan ones, tan of 45, to write down what they are before I start. And those are the two tan values. Okay, tan of 45 is 1, tan of 30 is 1 over root 3. And so now we can plug in. So we have 1 minus 1 over root 3 over 1 plus 1 times 1 over root 3. And we're going to rationalize this denominator. So we're going to multiply the whole thing by root 3 over root 3. And that's going to help us rationalize this. So if we multiply the numerator by root 3 over, then we get root 3 minus 1. And if we multiply the denominator, we get root 3 plus 1. Now, none of those matches this answer because they've rationalized their denominator further. And you remember from Algebra 2 that you can get rid of, when you have a radical with a plus or minus, you can get rid of the radical by multiplying by what we call the conjugate. So we're going to go root 3 minus 1 for the top and bottom. So this is the fraction that's equal to 1. And when I change this sign, that makes it so that the radical will go away when I FOIL. So the denominator of this becomes root 3 times root 3 is 3. Plus root 3 minus root 3 cancels, but I'll show you what it is. Plus root 3 minus root 3, and then minus 1. So the denominator of this becomes 2. The numerator, when I FOIL this out, I get root 3 times root 3 is 3, minus root 3 minus root 3 plus 1. And so the numerator becomes, let me see, I'll try to finish it up over here. So the numerator of that becomes 4 minus 2 times root 3, and the denominator is 2. And so that becomes 2 minus radical 3. And so the correct answer to this one is B. Okay, so that's how you use these formulas to evaluate the exact answer for sine, cosine, and tangents of angles that are not the angles that we know from our unit circle and our special right triangles. And so now you're going to have a chance to do a couple in your textbook, okay? And you are welcome to go look at the proofs that I've posted as well, but you don't need to do that today. Okay,